Okay, so this question here is really easy, right? But it tends to come up at the end of the paper, right? But actually, if you employ this skill I'm going to show you now, you'll have no problem at all. The key to this, right, is ignore any big numbers, okay? Now, when I mean big, I mean like the 2 there, right? I don't mean the power, right? The power is important. But like here, for instance, ignore this 4, ignore this 3. It's not important, right? It really is not important. Ignore this 5. Sometimes they put like pi in front, right? And if you think about it, even though pi is actually a letter in the Greek alphabet, in maths, pi is 3.14, isn't it? So that's a number, so we'd ignore that, right? But any letters like A, B, X, Y, Z, any letters are important for us. And here they just want us to look at the sort of dimensions of this, right? And they say in here this is an area. And of course, if you think about it, it is. If we ignore that 2 there, it's not important, right? But if you think about it, AB, right? AB is like what you get from in areas. And if you had a rectangle and, you know, its length was A and its width was B, right? Well, to work out its area, you do A times B, wouldn't you? AB you'd get, okay? So it gives you an area. C squared is also an area because that would be like a square, wouldn't it? Okay, square, where, you know, maybe both sides are C, so the area would be C squared. Now, if you add 2 areas together, so these are like tiles, and if you had a big tile and a little tile and put them together, you're still getting an area, aren't you? So it's really important there to understand that. When it comes to the second one, we've got to decide, is it a length, area, volume, or none? Okay, it might not be any. So in this case here, as I said, ignore the numbers. And we look at here, and we just look at A. Let's think about what A represents. A just represents a side, isn't it? Or length. Okay, so we've got A. Okay, it could be like that. B. Okay, B, again, represents a length. Okay, could be bigger length, could be smaller length, doesn't matter. C also represents a length. Okay, and here we're adding them, taking them away, and so on, right? And you know, you're multiplying A by 4 there. Okay, so if you've got A there, multiplying it by 4 just makes it 4 times bigger. It's not important, it's still a length. But if you put these lengths together, okay, you might be adding them, taking one away, you're still going to end up with a length. Okay, so that's so important to recognise that. When it comes to this here, and as I said here, you've got 5 times all this here. 5 times, it just makes it 5 times bigger, so it's not important. It's these that matter. A times B squared. Now think about how many dimensions are there. Okay, think about how many dimensions are there. That's actually 3 dimensions, isn't it? Because this is like doing A times B times B. Okay, that's what B squared is, isn't it? A times B times B. Now think about when we times 3 times together, it gives us a volume, doesn't it? It gives us a volume. Okay, it's like volume of a cuboid, isn't it? You know, we do length times width times height. And that sort of thing was going on here, isn't it? You know, could be that the length and the width are the same. That's why they've got B squared there. But there's 3 things being times together. Now, when it comes to this one here, this is one where we've got to watch out for, right? Because here, AB, what does that represent? We've seen it up there with me, area, okay? But what does C cubed represent? C cubed is like C times C times C, isn't it? And we just discussed that, C cubed. Just discussed that. That would give me a volume, wouldn't it? Now think about it, area and volume. Does that make sense, adding them together? You know, if you've got like a flat sheet of paper and you worked out the area of it, and then you've got a cuboid and you worked out the volume and you added them, it wouldn't make any sense, wouldn't it? So it represents none. It doesn't represent anything. So you just say none. At the bottom then, they've been a bit nasty, right? But they put in a bracket, but we can multiply out brackets, can't we? If you times everything in here by C, you get AC plus then 2BC. Okay, so A times C, 2B times C. You get this now. AC, of course, represents area, doesn't it? BC, ignore the 2, it's not important. BC also represents area. So you've got an area plus an area. Of course, that will give you a bigger area, but it's an area all the same.